In this problem, we have a massless simple beam with length L of 10 meters that has a force of 21 kilonewtons applied at the center of x equals 5. We want to find the load reaction of each support and plot the shear and moment diagram for this beam. We will also be finding the max shear and the max moment. Due to this being a Stag's problem, where there is no movement, the sum of torques must all equal 0. We can use this to find the force on the support that is pushing back. We will be treating the leftmost support as a pivot point. Plugging in our values of negative torque from the load and positive torque from the support into the sum of torque equation, we get that the support is pushing back with half the force of the load, which is 10.5 kilonewtons. Being that the total force pushing down must be cancelled out by the supports pushing up, the other support must be carrying the other half of 10.5 kilonewtons of load. Now to make the shear force diagram. The way we go about this is looking at the beam from left to right. Anytime we hit a force that is going up, we add it. Anytime we hit a force that's going down, we subtract it. So first we hit the force from the leftmost support, which is going up, so we add plus 10.5 kilonewtons, which we will plot in the shear diagram. We continue at 10.5 kilonewtons up until we hit the 21 kilonewton force going down. This is going down, so we subtract this load. Now we are at negative 10.5 kilonewtons. We continue at negative 10.5 kilonewtons up until we hit the rightmost support, which is applying a force of 10.5 kilonewtons up, which will be added, so this cancels out and we are back to zero force, which puts us at an equilibrium. Our max shear force on this diagram is 10.5 kilonewtons, which is the same as the support's reactions. Now for the moment diagram. The moment diagram is going from left to right and adding up the area underneath the line created by the shear diagram from left to right. So if the area is above the axis, it is positive. If it is below the axis, it is negative. So going from left to right, we are adding up the area up until we hit the load, then the area underneath the shear diagram is negative, and we start subtracting the area. To finish off this video, we need to find the max moment. Looking at this graph, we can see logically it happens right at where the load is in this case. So we need to find the area under the shear diagram up until that point. We have a rectangle with height of load divided by 2 and length of half of the total length. Plugging that into the area of a rectangle formula of base times height, we get that the load force times the length divided by 4 is equal to the max moment. Plugging in our numbers, we get a max moment of 52.5 kilonewton meters. Poll update. This video adds one more video to statics and strength of materials. That concludes this video. Hope you'll have earned a like, share, or subscription. If you enjoyed this video, you may enjoy one of these videos as well.